So let me show you an example of how you can create generative AI applications using MariaDB and a technique called RAG. So on the one hand, you have a gigantic data set like the internet, Wikipedia, books that is used to pre-train a foundation model like GPT, Llama, Mistral, and others. And on the other hand, you have your user, which can be a human or an application that introduces an input into your application, maybe developed with Java, Python, Node.js, C++, any other language. And you have your own data over here, but this foundation model, it doesn't know this data. Maybe it's private. And you want to use that data to generate the output from your application. So for that, let's study the case when the user is writing data. For example, maybe they want to update the description of a product to something else. So this is sent to your application. Before running this update, you can send that to an embedding model, right? So it's another AI model called embedder. You send that input is in this case the new description for this product, and then the embedder generates a vector, which is a series of numbers that represents kind of the meaning of this sentence. Now you can store the input, the new description of this product, plus a vector, so this series of numbers, in MariaDB, because we have now a new data type that allows you to store these vectors. Now, all descriptions, all the products are going to have a vector, right, based on the descriptions, the idea here. So let me show that in code. So I have this project here. This is Visual Studio Code. And there's a bunch of files here. There's a README that you can follow if you want to run these locally. But first, let me show you these Docker Compose file, which is what sets up all the infrastructure. So we have two services, MariaDB and something called LocalAI. Okay, so MariaDB, we are just setting a password for the root user and creating a new database called demo. And then we have a script here. I'm not going to go through the details of these, but there is a schema, the SQL right here, which creates a table for storing products. And I have downloaded these CSV file, which I load here in the script into database. So when the container starts, you have some data already. I think there are like almost 1,000 products here. Now let me show you that database here. So this is the localhost 3306, which is this port over here. And you see the product table with a bunch of columns. The interesting one in our case is this one that I added here, embedding. And notice that, let me click that. It's actually a vector. So you can create columns to store vectors. These numbers, the dimension, how many dimensions these vectors are going to have. In the case of the embedder that we are using, it has 2048. And so that's where I'm specifying that number there. So make sure that you use the correct number of dimensions. Let's get back to the Docker Compose file, because we have another service here called LocalAI, which is a way to run AI models locally. And I have two models. So BERT embeddings, which this is our embedder, and Phi2, which is it's not an LLM, but a small language model, right? So we can run it locally in our own computer. And this is going to be listening on this port, 88. Okay, so first we need to compute the vectors, right? So we have a bunch of products, but we need to compute the vectors. And for that, I created this program. I don't have any frameworks here. I'm not using any frameworks. I want you to understand where things happen and how and who is doing what. And I'm using Java with something called JBank. So you don't even need to install Java. You can just invoke these file from the command line I'm going to show you in a moment. Okay, so I'm using some libraries, but these are not like big frameworks or anything. At least not AI frameworks. The important thing is here is the entry point of this program. I'm connecting to MariaDB through JDBC. This is localhost 3306, the demo database that we created. And then I'm creating a query, which is all this stuff here. This is a multi-line string in Java. And what it does is it's selecting a bunch of things from the table products. It's actually two columns. So one is for the ID of the product, and the other one is that's like a string, kind of concatenating information about the product, like the product name. Then in parentheses, we have the category name and the root category name and the price and the final, the rating. And then after that parentheses, we have the full description of that product. So we get all the products in this kind of format, right? So we have the ID and a bunch of text. Now I'm interested in the products that don't have any embedding calculated yet. I execute that query and then I iterate. We get a table here. We iterate on the rows returned by that query. We get the ID. We get the product summary, which is how I called all these concatenation of things. That's the product summary. So we're getting that now into a Java string. That's what we are going to send to the embedder, right? So we need to invoke it. And for that, we need request body. Remember, I'm not using any frameworks here. Frameworks make these much easier. You'll end up with less code, but I want you to see what's going on under the hood. So we have a JSON object here. We specify which model we are going to use. We're going to use embedder, BERT, embeddings, and the input is going to be injected here according to these stuff. Don't worry about this, is so that we get a valid JSON string. The important thing is that the product summary is going to be there, right, as calculated by this query. We have that string. Now we invoke the endpoint where the embedder is running. So it's localhost 8080, and this is the path. Now we send this request body that we generated here, which contains, remember, it contains the product summary. And then once we get the response, so this is going to be a bunch of JSON, right? We can leverage JSON functions in MariaDB to extract the actual value of the vector. And we use that to update the embeddings or embedding column in the products table. So we're extracting just one part of that big response. We are only interested in that part. So I inspected the JSON that the embedder returns, and then I figure, okay, this is what I need, right? And then I need to convert that to the appropriate format for MariaDB for the vector data type. For that, we can use this function, vector from text. So now we can set that value into that. Obviously, where the ID corresponds to the ID that we were interested in. Remember, this is a for loop, so we're going to do that for all the products in the database. And then we just log something like this, updated embedding for product ID and the number of that product. At the end, we just show all embeddings updated. This is going to take a lot of time, but you can run it like this. I think it was, how did I call this? Compute vectors. I already done that, so it doesn't do much, but actually I'm going to show you here because I did it before. And then it's going to log all the IDs of the products that are being calculated. And I was going to say all embeddings updated. There are 952 products in this database. So let's focus now on when the user wants to query your application, your data. Let's say we are building a chatbot that suggests products, a recommendation system. So maybe the user, or maybe it's just a chatbot for something. In this example, we are saying the user is interested whether product A works with B, for example. So this person sends that string to our application. We take that input and we send that to the embedding model again. This input is the question the user has. Does A work with B? Now we get a vector that we are not going to store. We're just going to use it to compute stuff. But we get a vector, all right? And now we can compare that vector with all the vectors in our database. That's called similarity search, right? And we can order which ones are closer to the vector corresponding to the input of this user. So we can get, for example, 10 products that are related to this. And then we can use that data. Well, we can append that to the prompt and then get a prediction, maybe the answer to the question that the user has. And then we send that output back to the user. So let me show you that in action. And we have another program here called Rack Demo. And it's kind of similar. It's using JBank and all that good stuff. So you can run it very easily. And don't worry about all the details. I just want you to understand the logic, the overall logic here. So this is my main program. That's it. So we have several parts. First, we get the input from the user. It's like a chat that's going to recommend products. So I'm looking for, and then the user types something. It gets stored in this variable, in this string. Then we say, okay, I'm going to find the closest products to that. I call these get context. We're going to see it in a moment. The thing is that here we're going to get all the products that are related to whatever the user typed. Then we're going to generate the response. So for that, we build the prompt, which is going to take the input, so whatever the user, again, typed, and the context, that's the products that are related to that input. And we calculate the response and just print it out. So let's go through all these functions. The first one is get context. Remember, it takes the input of the user. So, well, we need to, again, build this request body. For the embedder, we send the input. We're going to calculate the vector, right? So we invoke the endpoint for the embeddings, sending that request body that we calculated here, which has the user input. Then we connect to MariaDB, and we create a similar query, except that this time, well, there are several differences here. We are selecting, again, the ID and then a string concatenation of things. I'm adding like row number here so that each product gets like 1, 2, 3, 4, 5, etc. We're getting only 10 of them. And this is the interesting part. We are ordering by something. And MariaDB has these function, for example. There are others. There's another one currently, but we're going to use this one, vector distance cosine, which is good for this use case. And this receives, again, two vectors. It's going to compare two vectors. One is the embedding column, right? That comes from the products table. We already calculated all the almost 1,000 vectors. And we need to extract, again, using JSON, the vector from the response that we got when we called the embedder using the input of the user, right? So we're going to calculate those two. And we are going to order the data based on these distance. And we're interested, again, only in 10 products. So we get the 10 products that are closer to whatever the user typed. So we got that. This basically is just concatenating all the products, right? We call this product summary, just like before. So it's using that. And it returns a string that is containing all the products that are, again, closer to what the user typed. This returns a string. Here is. Okay, so that's get context. Then we use that context to build the prompt. So let's go to that function, which is down here. And this just returns a string, right? And here's the what we're going to send to the actual LLM, or in this case, SLM. You are an expert sales assistant. Help me choose the best product for my needs. Recommend only one product from the list below and explain why it's the best choice in one short paragraph. I'm looking for, and here is the input of the user, right? It's going to be injected here. And then available products, another string, is the context, which is what we calculated before. That's build prompt. Let's get back to the main method here. We have the prompt. Now we just need to get the response based on that prompt. So let's go to that method here, get response. We get the prompt. Again, we need to build the request body. This time is different because we're using another model called Phi2. And we are going to say this is just the format that this model expects, right? These JSON object here. So we're going to say, hey, the content, this is what gets sent there, right? For role user, the content is going to be this, which is the prompt. Then you can also calculate the temperature to, configure how creative these answer, the prediction is going to be, and the number of tokens, maybe a limit. So we're going to use 150. So it doesn't just continue to say a whole lot of things for this demo. Then we invoke that model, which is the path is a bit different. So we have to change that. We send a request body. Again, don't worry about all the details. Focus on the flow of data here, what's going on. And somehow we use Java to get the message, the answer from the LLM or SML in this case, which happens to be through all these. I'm going to leave that as an exercise to you. You can basically inspect what gets returned here. It's a string and understand why I needed all these code here. Just kind of traveling through the JSON string to get just what we need, which is the answer. So that's the get response method. And we just print that out here. Okay. So let me execute that. Rec demo. And now we are the user. So let's say looking for lightweight women's running shoes. The first bit is very quick, finding closest products. Remember, this is where we calculated the vector for this string. So that's fast. And then MariaDB is super fast to get the vectors. Even if you don't use a index, pretty fast because we only have 1,000 products. Now, when you have millions, you can create a vector index. All right, we got our response. So based on your needs for lightweight women's running shoes, I recommend the Isitana women's walking shoes, lightweight, breathable, blah, 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 blah. So yeah, it actually worked. It's using our data. So if we go to the database, we're going to find a product with that name for sure. That's RAG in action. That's MariaDB with the vector search in action. Please check the documentation. There's much more to it. I just showed you the bare bones of a RAG application with no frameworks. Please use frameworks depending on the programming language that you are using. Use, for example, Spring AI. There are integrations for MariaDB already. That's going to reduce the number of lines of code that you need, and it's going to make it easier to maintain because there are differences between the AI models. The framework's going to handle that for you, so you don't need to worry about making requests to a server, and it's just much easier to build these kind of applications. I hope you like this video. Let me know what you think. Let me know what you would like to learn next. Thanks for watching, and I'll see you in the next one.